So after reviewing it, I did get the right answers. And to show you, we know the insiders lie. So when we write this as the vertex, you're going to have the point -3 because insiders lie, comma 1. And that's your point where your vertex is on the graph. So if we were to draw this out, this point right here on the vertex, its lowest point, will be -3, 1. And that's that's our first part. We needed to find the vertex. So as for the maximum and minimum, well, on a graph, on a quadratic, you see that the minimum point, in this case we have a minimum because the line opens up, and the lowest point on this is down here. And that's its minimum value, its vertex right there. So by getting the vertex, we got its minimum value. And to show this in integral notation form, we're going to put this in terms of x. So what we're saying is that x, our variable, any number, x stands for any number. X could be any number as long, or we're going to show that it's decreasing. I'm sorry, let me back it up. So we need to show that it's where it's decreasing and where it's increasing. We know that if we split it right down the vertex, or is our line of symmetry, we can tell that if this were on a graph, this point right here, this line, is going downward like a roller coaster. It goes down from this half, from this point, from the point of its vertex, from all the way up here. We'll call this negative infinity, because that's what it is. From negative infinity all the way up until this point, it stops. That's where it's decreasing. And we can tell from this point all the way to infinity, it's increasing. So to say that in integral notation form, we can say that x, for decreasing, we can say that any number, which is x, if x is greater than negative infinity, if x is greater than negative infinity, but smaller than -3, then this value right here is decreasing. Because that's what we're saying. We're saying that negative infinity is less than x, is less than any point right here up until -3. So that's our decreasing. That's how we show where the graph is decreasing. To show where it's increasing at, we just do the opposite thing, like a mirror. We say that x, any number, x is a variable, any number that is greater than -3, any number that is greater than -3 on this graph, but less than infinity, because it goes all the way to infinity. Pretend like infinity is a number in this case. So x is greater than, any number is greater than -3, but is less than infinity, is increasing. So that was number 57.